Good afternoon, everyone. My name is Laith Al-Sadoun. I'm a senior solutions architect at Amazon Web Services, and we're so excited to have you here for reInvent 2018, and delighted to have you in our Data Lakes session today. It is my great pleasure to be on stage with Greg and Varun from Sysco today, who are going to share their journey and their technical architecture for building data lakes on AWS. Just to quickly recap, Sysco presented yesterday on their legacy application migrations into AWS, and you can find that session later uploaded on YouTube, so please check that out. And tomorrow, we'll be holding a Chalk Talk for customizing data lakes for your enterprise, where we'll dive even deeper in the technology. So first, I'm going to let Sysco share their story and their journey for building data lakes on AWS, and really get to dive deep in their technical architecture. I'm very excited and thrilled that they can share that with you. And for the second half of the session, I'm going to dive deeper into some of the technical best practices and architectural patterns that you can use to build your own data lake on AWS. And with that, I'm delighted to introduce Greg Nelson. Thank you.
All right. So thank you, Laith. And thank you, AWS, for allowing Sysco to share our story into the cloud and the building of our data lake. I'm Greg Nelson. I'm responsible for reporting and analytics at Sysco. And before we get into the discussion, I want to tell you a little bit about the company. So we are the global leader in selling, marketing, and distributing food to restaurants, healthcare and educational facilities, lodging establishments, and really any customer that prepares meals away from home. In fact, while you're here at the conference, there's a very good chance that you'll eat or consume food that's been hand-delivered by one of our trucks. So you'll notice on the slide our 4 strategic priorities. And one of the first things you should see is customer. And that's actually our vision statement is to be our customer's most valued and trusted business partner. One of the other things you'll see is operational excellence. So at the heart of a lot of what we do at Sysco, we're a logistics company. We have over 100 physical warehouse locations where we ship and deliver food to our customers, as well as the 3rd largest privately owned fleet of delivery vehicles in the continent. To give you a little bit of a better feel of the size of Sysco, we do about $60 billion in revenue annually. We're number 54 on the Fortune 100, and we've been doing this for almost 50 years. So we started in 1969, and we're a company that has grown mostly through mergers and acquisitions. And if you take a look, this is where we're doing business today, places like the US, Canada, Mexico, parts of South America, and over in Europe as well, overseas. So now you know a little bit about Sysco. Why the data lake at Sysco? So at Sysco, we had an EDW. We had a central place to store our data. We could do reporting and analytics. Why did we need a data lake? And the problem came into play where we started running out of capacity and having performance constraints. And while we had those issues, there's new business cases that we wanted to make available. So you'll see things like clickstream, machine learning, data science, social media data, as well as just transactional ERP data from companies we were acquiring. So we were kind of in this paradigm where we had to do this cost-benefit analysis of whenever we wanted to move this data into the enterprise data warehouse, we were kind of looking at the ROI as, can we do this? And if we can do it, is it the right data set? If we're running out of space, do we need to buy more infrastructure? And that usually meant spending millions of dollars of upskilling and buying new appliances. And that's what I call the wall of business constraints. So you see it there. It's a nice pink wall, should be on the slide. And I know what you're thinking, Greg, hey, it's a short wall, it's pink, can you get over this thing, what's going on? And what I found out was the pink is actually ectoplasm. And for you guys that are not Ghostbuster fans, that's pink slime. It's not easy to get over. I've seen people that are in very good shape, they have the 26.2 sticker on the back of their vehicle, run up, slip off this thing, and fall on their face. So I'm making light of a situation, but the reality was we really kind of came to this point where we had to make a decision. Were we going to invest additional capital to advance in some of these use cases, or we were not going to advance our data strategy at Sysco at all? So what were we going to do? That's where I introduced to you Seed. And that's our branded data lake. It stands for Sysco's Ecosystem for Enterprise Data. And that gave us that central place, that central repository to store our data, but so much more. So now we have actually our BI tools in the infrastructure. We have analytic engines. We have MDM data, new types of data we couldn't work with before, like images and text. But the main thing that really moving into this building the data lake changed for us was this paradigm, which by leveraging the cost effectiveness of the cloud, we could now not have to do an ROI analysis every time we wanted to put more data in the data lake. So for example, we could stand up an S3 instance, put third-party data in there, expose it to a data scientist or a data analyst. They could prove out their hypotheses. If it had value, we could scale it. And if it didn't, we would deprecate that asset. And so that's a whole new way, a whole new paradigm of how we look at Sysco. And that's one of the biggest value props that I see by moving into the lake with AWS. There's some other business outcomes that I'll get to in a minute. Before we do that, I want to tell you a little bit about the journey. So in the journey of moving to the cloud, we definitely had some failures, and it wasn't easy, but there was kind of three guiding principles that we found and we learned. So one was start small. We found a use case that we could start small on, and it goes back to we didn't have to make this big capital investment in a new appliance or new infrastructure. Secondly, we learned we could pay for what we use, and I'll talk about that in a minute. And lastly, fail fast and pivot. So the flexibility of the AWS marketplace, I'll give you an example of that in a second. And the way we attacked this was by data subject area. So for us, that meant things like merchandising, sales, supply chain, operations. And we started with a use case around merchandising. And basically, we took that legacy data, put it up in the cloud, and exposed it to our merchandisers, and they did business acceptance testing, and we found out, hey, this thing works. So let's move on to the next subject area. We think we can really scale this out. And we moved on to sales. And sales, we actually do about 80% of our analytics around sales. So sales was tough, and that's where we started, I guess, in facing some of our challenges, and we had some failures there. So some of the ETL patterns that we're using for a traditional relational database, they didn't work in the cloud, to be honest, or at least they weren't performant. So we were able to fail fast and basically reach out to our AWS partners and spin up things like EMR clusters and use PySpark patterns to do upserts instead of updates. And that's because we use Redshift as our columnar data store, kind of our central database application for our ADW. So we learned from that and pivoted quickly, and we did not lose our budget it wasn't at the risk of our timeline, our project timeline. So that was great. Moving kind of through the different subject areas, you kind of see we moved to supply chain and then all data sources, and then finally, we're in the cloud. So our data ecosystem at Sysco is fully in the cloud as a little over a year now. So we're very proud of that, and that's something we want to continue to leverage. Two things before I move on from this slide. We talked about pay for what you use. So as we were deploying these different subject areas, we found out that we needed to do end-to-end integration testing on a production-like environment. And that's what AWS gave us the flexibility to do. So we could actually spin up a production-like mirror and do our testing. It meant we were going to pay a little bit more, maybe for a couple months, but then once we deployed that, we could spin that infrastructure down. And that's flexibility we didn't have before. Secondly, I'll call out when we were about to go fully GA on Seed, so we're about to send out the comms to marketing and throw the big party, we had a bad data load. It was actually at the S3 staging layer. So the great thing about S3 is it comes with data redundancy out of the box. It makes 3 copies of your data per availability zone, and you can set that up to scale across the globe. So typically what that meant was go back to our data source systems, find the deltas, figure out what reports we missed, and that was usually a week-long exercise. Instead, we were able to go to that S3 structure and point it to the backup, and by the end of the day, we had our warehouse loaded and our reports delivered. And so that was a big win for us as we were going live with Seed. So lastly, I'll talk a little bit about outcomes, and then we'll hand it over to Varun to talk about some of the best practices. So this right here, what we're showing you is some of the reporting we do in Sysco. And so we talked about how long we've been in business, and some of these reports, they've been in existence for 20 plus years. So that's why you look at the bottom left corner there, formatted reporting. You can kind of think of that as your canned reporting, kind of columnar in nature. And we have a lot of reports. I can tell you horror stories of us bursting out over 200,000 reports a day. But we knew we wanted to do more things on the right. So some of the exploratory and higher value analytics, so things like visual analytics, data science, predictive and prescriptive analytics. And what AWS really allowed us to do was to do both, and that's hard to do. So we were able to modernize our infrastructure. So by moving into AWS, we actually have seen a 50% increase in our data load times, and that also means data or report delivery. So we're actually delivering faster, we're modernizing our infrastructure, and there's more room to grow there, so we can make things even faster. While we're doing that, we had some use cases that we were able to enable around machine learning and data science, so things like personal recommendation engines that we really couldn't do at scale before. So think about merchandising and customers who bought this, also bought this. We could expose that to our e-commerce experience as well as our sales staff and make recommendations to them as far as what kind of products maybe they should be suggesting to customers. Another was, you can see their churn model, and also a use case around being able to search for items. And what we did for that was around leveraging DynamoDB and Elasticsearch. We actually made a capability and put a UI on top of being able to look for item substitutes. So now with attribute data, I can do things like type in chicken breast, frozen, 6 ounce, and actually get a list of results of comparable products that I can use as a substitute, and I can even give SKUs. And using unstructured data, we can show pictures of that now. That was all done in the data team. That wasn't an app dev effort. So these are things, these are powers that we've kind of unlocked within this infrastructure. And I'll leave you with this before I turn it over. One of the things, I guess, is an unintended outcome. And that is, before we moved into the cloud with AWS, I would call our team a team of data developers. So you think about DBAs, data architects, data modelers, ETL developers, SQL developers. And what AWS has allowed us to do is get closer to the open source cloud. So we're using tools now like EMR, PySpark, Hive, Pig. We're building our own custom data applications. And really that's raised the bar and the skill level that we have at Sysco. And so now we've moved from what I call a team of data developers to a team of data technologists. So with that, thank you for your time. I want to hand it over to Varun. He's going to talk a little bit about some best practices we found while moving and building our data lake. Sure.
Thank you, Greg. So as we get started, you heard Greg talk about the why. I'm here to talk about the what and the how. And before we get started, I wanted to take a little bit time to specifically introduce to you Seed Data Repository. Data Repository is the endpoint that we have that enables our data lake. What is in that Seed Data Repository? So we have all our data. We have the transactions, the observations, the interactions. from third party, from all the different other sources. And we have our models that we use on our data set, from personalization, price migration, assortment, or customer risk, and other models that our data scientists and other individuals really need. Now, as we move towards and start talking about the how, I want to take you through the architecture, talk about some of the customizations that we have done on the data lake reference architecture from Amazon, talk a little bit about some of the lessons that we have learned, and then finally finish off with where we are on the roadmap and where we are trying to go. So with that said, let's quickly go talk about the architecture. As you see, from a seed architecture perspective, we use the reference architecture that Amazon has for a data lake implementation. That reference architecture is an API endpoint that uses API gateway to log into the microservices for data lake. Now, those microservices are Lambda enabled, and those microservices have opportunities or solutions to create packages, configure packages, load data, update, configure security, and so on and so forth. That is the place that we started. I want to take your attention to the items in the pink. The basic services on the reference architecture is really there. But from a data lake implementation, the first thing that you really want to sort out, even before you do security from our perspective, was to figure out how we are going to ingest data. How we are going to ingest lots of big data. How are we going to ingest lots of small data? How are we going to ingest data on a periodic basis? So we wrote our own custom module. We like to call it Gravity, that allows us to ingest data on a regular basis to our data lake. The source can be a Redshift environment. It can be an S3 bucket. It can be any other external data source that are sitting out there, and we can ingest that data set within our environment. The other thing that we added post that was our integration to some of the outbound services that AWS provides. So here you see we have an integration to DynamoDB and integration to Elasticsearch. Now, why is this important? So from a reference architecture perspective, this is where you separate compute and storage. All our data is sitting in S3, and through DynamoDB and Elasticsearch, we have an opportunity to enable endpoints that give our customers API-based access, give our customers a search-based access to our data. At the end of the day, that frees up your data to be more of a services-oriented work versus trying to just go by doing all kinds of reporting and SQL on the data set. The third integration that we added was of security, because now we were ready to deploy the solution out to the workforce. And the final fourth integration that we added to this data structure was for making sure our data was available to be used in the at-scale infrastructure. What does that mean? The data that is sitting in S3, I can spin up my own Redshift cluster and work with it depending on my needs. I can query the data in Amazon Athena. I can even take the data to build models in EMR as well as SageMaker, as the case may be. So given this architecture, these are the 4 customizations that we've been able to do on the reference architecture to meet our need. I want to pull 2 of these customizations out and talk about it in a little more detail. The first customization that I want to pull out is specific to the DynamoDB and Elasticsearch. So let's pull that out and talk about it. Now the data is sitting in seed already. Every day we have new services coming from Amazon. There are use cases that are coming around time series databases that we saw this morning. There are use cases that are coming around on the graph-based databases that we see in the morning. We want to enable our developers to have the right tool for the right jobs. And that's why data in our data lake can be consumed through any such service that Amazon has and enables us to be successful. And that's how just separating compute from storage gives us the use cases that we need for our end consumers. The second use case that I want to talk about is specific to the at-scale prototyping or the at-scale work that we have in our data lake. So we give our data scientists endpoint to build their own EMR clusters or an EC2 instance with Python libraries, or in this case, our libraries preloaded and available to them to do their analysis. Now, what that has done is that has really accelerated the innovation that our data scientists are bringing to the table. We have built solutions that we couldn't build before. We have a live driver compliance dashboard that's enabled via the IoT devices that we have on our trucks. So now in real time, we can give feedback to our drivers on what they should be doing to meet their delivery window and their performance expectations. Similarly, we've been able to integrate and build a custom recommendation engine that looks at our click streams data, that looks at our transactions, and is able to recommend the right product for our sales force, for our customers, and even on the e-commerce channel. And then finally, we've had instances where Sysco carries about 500,000 different items. There's an opportunity for us to take what is sold in one region available to other region. And through the investments that our data scientists have been doing on the platform, we can do some of those use cases because there's a lot of search and matching that is available on those environments. Moving on, not all of this has been without a lot of learning. So I want to consolidate learning into 4 things that I want to leave you with. What are those 4 things? The first is a catalog centralized repository. The data in the data lake is really not very useful if you don't have good metadata to go with it. And this is where a foundational data structure needs to be able to integrate solidly in everything that your end users are doing. So there is this opportunity for you to make sure that everything that you bring to the lake is cataloged, is curated, and is available for people to consume. That was one thing that we ran into fairly quickly. The other thing that I want to talk about is data as a service. You heard Greg mention that we had thousands of reports, so 200,000 to be exact. One of the things that a data lake gives you is this publish, subscribe architecture. So end users can publish content. There are consumers that can subscribe to content, and there is no need for us to burst a lot of reports out there. That has worked out to be more of a change management issue than more of a technology issue. So that's something that you will get into when you talk about the migration. Third thing that I want to talk about is a rapid experimentation platform. If you're building a data lake, and if you're not allowing your end users to take advantage of the data lake by giving the builders the tool that they need, it's all of the data is sitting here without really being used. So there is this opportunity for you to really unlock and enable all the individuals that can do something with it to really use the platform. And this specific case, one thing that came to fore was we have all heard of shadow analytics done in the business teams. People have their own databases. They configure the database, update it, work on it, and they do the analysis in a silo. The opportunity there is that you need to talk to those individuals and bring them to the fore. The only reason they are not on the platform is because you cannot iterate as quickly as they want to. And this is an opportunity for you to kind of bring those individuals back into the fold to work with you as you build that platform. And then finally, data lake is an investment. You are putting a lot of data in there. If it's manual, if you're updating data, if you have manual corrections, and if you're doing a lot of reprocessing, it's really not going to scale and work for you. Invest in automation. Every repeatable task that you have in your environment that needs to be automated and be available for your end users to take advantage of. So with that lessons learned, I want to talk about what are our priorities as we move forward. Last year, we stood before you and spoke as a seed team. Seed was the starting point of everything. We had a basic data ecosystem on cloud, and we had rudimentary tools to work with the data set. We had predominantly batch-based scenarios. Since then, we've made the journey. We're moving towards seedling to sapling to finally to a tree. So what do these different things mean for us? From a seedling perspective, we want to build a centralized repository that is curated, that is cataloged, and that is available for our end users with good kind of data provenance, as well as the opportunity for automation around how I update data in. As we mature, we want to make sure that our data scientists and all other individuals that are on our platform are able to build and scale our machine learning models. And I like to call that enabling data as a service. So it could be these individuals are coming to you with a notebook endpoint. They are data developers that are trying to integrate your data into their products. So they need an API endpoint. They are coming to you with a SQL query. Whatever have you, there's an opportunity for you to enable data as a service, and that's where we think a sapling is kind of a place. And then finally, a tree. Tree for us means really accelerating the analytics velocity of the organization. We need to iterate quickly and rapidly on the analysis and make sure we have a good understanding of what is production and what is exploration. And that's how I see us maturing as we move forward. With that, I'll forward it to Laith to talk more from a best practices perspective for a data lake.
Thank you very much, Varun, and thank you, Greg, again, also for sharing your story. Really quite inspiring. How many folks here are currently starting to look at or building data lake? Just a quick show of hands. Wow, really great number. Thank you so much for sharing that. So I'm going to dive into some best practices and patterns that we see across customers. I have the great fortune to work with a small group of our millions of active customers every month in the Houston, Texas area. And again, I'm very glad to be with you here today. But first, just a quick background on where our customers are coming from. For a long time, analytics and data architectures have existed in these data silos, where these engines and platforms are dissimilar, they are heterogeneous, and that presents some challenges, right? There are both licensing implications, infrastructure scaling implications, and I want to talk about 4 key functional challenges that we have seen with customers. The first is that in these dissimilar data engines and data platforms, it becomes very difficult to perform queries and analysis over all of your data, right? And you have to introduce complex, sometimes fragile, extract, transform, and load, or ETL logic into that. And that produces data copies. I know customers who have dozens of copies of their data or more. And it produces a complex scheduling and so forth in those systems. The second is the ability to support data types and formats. With for instance, a traditional relational database architecture, you're stuck with schemas that's enforced when you write the data, and it becomes hard to adapt to new data types, right? Data types being int or string or something else, or data formats, whether that's something unstructured. And this also is attached to the next topic, the next challenge, which is real-time streaming data. The traditional data architectures, customers have found it hard to scale traditional architectures for the throughput of real-time processing, as well as the dynamic nature of real-time processing, right? And that dynamic processing or dynamic data types of streaming data that often comes in, right? Oftentimes, you'll add a new field into your streaming data, or for instance, in your sensor data from IoT, you're going to add new telemetry, a new field to that stream, and it becomes hard to adapt that to your traditional data lake, traditional data architecture. And lastly, because these systems are dissimilar, whether it's in a relational database or a Hadoop cluster or an EDW on-premise, they have different security controls, different APIs, different control planes, and different scaling mechanisms. That it becomes very hard, or if not impossible, to apply consistent security and governance policies over those data sources. And so, translating that to why customers build data lakes. First of all, a data lake is a single repository to collect all of your data, whether that's business data from ERP, transactions, streaming data from clickstream or sensors, as well as even unstructured data like imagery. We have customers in oil and gas collecting seismic data, video clip data, and more, all on S3, which we'll talk about. And that's really the important aspect, that you need a storage platform that can support that rapid growth of data and virtually unlimited types of data. The second reason is that we see data lakes being used to support a diverse set of customers. Like Varun and Greg mentioned, you have not only traditional business analysts, but now you have data scientists and even your developers who need access to data to make more intelligent applications. And so as you're building a data lake, these should be some of your tenants that you should be able to consider a wide range or support virtually all of your data consumers in your business and external consumers. And with that comes access mechanisms, right? Developers need access to APIs. Your analysts still want to do business intelligence using SQL queries. And machine learning experts and your data scientists need access to store and collect training data and use things like notebooks on Jupyter or Zeppelin and so forth to train their machine learning algorithms. So just to quickly recap, collecting all of your data is a key part of, in one place is a key part of your data lake strategy. You should be able to dive in, meaning you should be able to both find an individual record in your data using something like SQL or REST API, and you should also be able to perform a large aggregation, right? If you need to run a query over just the last day of data or the last 10 years of data that you have, you should be able to do that with ease and support a wide variety of tools like BI tools on the marketplace, Jupyter Notebooks for machine learning, and it should be capable for the very fast-changing landscape for big data and machine learning, right? Seems like every day there's a new machine learning framework, there's a new big data tool from Hadoop, right? And you need to be able to support that through using open file formats like CSV, Parquet, ORC, and so forth, especially for your business-related data. The last tenet I want to mention about data lake, and then we'll dive into what are the key AWS components and how you can do this. Varun mentioned this, but you really need to consider separating your data from your storage, separating your storage from compute, excuse me. When you have a traditional architecture, you oftentimes have to vertically scale or even horizontally scale a data warehouse or a Hadoop cluster simply just to add more storage, or vice versa, right? For instance, Hadoop HDFS has a default replication of 3x, and you have to kind of scale out data nodes where you may not need compute. So by separating your storage from compute, that gives you a lot of advantages, right? You have the ability to use the right tools for the job. So you can bring, say, Spark to your data lake, or you can bring Flink. You can bring ML frameworks like TensorFlow or MXNet to the data lake, so you can use exactly the right tool for the job. You now have the flexibility to scale these independently, right? As your data grows, it may grow at a much higher velocity, at a much higher rate than just the compute itself. Third, you have the ability to use temporary compute resources on your data, meaning oftentimes you may produce a pre-computed view or turn out a report from the data lake, but you don't need a cluster or EC2 instances running 24/7. You can simply run that and orchestrate your compute just like you would orchestrate the job itself, and we'll dive into that a little bit later. So S3 by far is the most popular object storage in the cloud, and for many reasons forms the best place to build your data lake on top of that. S3 has designed to provide 11 nines of durability by storing multiple copies of your data in multiple facilities, and we handle the replication, the error checking, and so forth. And it's very economical, right? And we have the different storage tiers. So we see that S3 is the center of the data lake for collecting and storing your transactions data, imagery data, audio from call center. The use cases are almost endless. Now, let's talk about some of the key components of the data lake. The first I want to mention is data ingestion. And while I would love to go in depth in each one of these icons here, I'm going to kind of glance over them, but just know that we're talking about high-level AWS services, right? We're not talking about building compute infrastructure every time you want to build a data lake. You can use our high-level services. So the first is ingestion, right? And you need a scalable pipeline, scalable network connection, most likely back from your data center, for instance, to collect things from your transactional databases, from APIs maybe that you're still running on premise. Things like Direct Connect can help you do that, and Storage Gateway. When you're considering your data lake building on top of S3, you do need the ability to quickly search and find your objects in the data lake and apply perhaps a secondary index over your data lake by using DynamoDB or Elasticsearch. And when you're using Hadoop frameworks, you need a Hive Metastore to run SQL queries over the data lake to use S3 as the external file system for those frameworks. So included here is also the AWS Glue data catalog, which allows you to run crawlers and infer the external table definitions for the data in your data lake. So you can simply collect data in S3 in a CSV format, ORC, Parquet, and run a crawler, and it will produce your table data definition language for that and allow you to query it right away. Security is always job zero, and if you've built on AWS so far, the tools and services are consistent, right? You have AWS Identity and Access Management policies for your users and groups and roles that you can use to control access to S3 buckets, control access to the Glue table and databases, and you can use CloudTrail, for instance, to audit and log the things that are happening, the changes that are occurring in your data lake. For instance, with the data lake reference architecture, you may want to apply additional APIs and UIs where you can use API Gateway, Cognito for authentication, and federated identity management from, say, Active Directory or even Facebook and Google using Cognito, allowing you to present an authentication layer or service to your APIs and your front ends. And last but definitely not least, we have to talk about the analytics and the serving. So there is a breadth and depth of services that you can use to provide analytics to your end users. For example, Amazon EMR provides Hadoop frameworks like Spark, Flink, Hive, Presto that allow you to run a cluster on demand in just minutes and run those queries by using S3 as the external file system. Just like if you have any experience with Hadoop, you know you have to use, for instance, HDFS. S3 allows you to use that almost as if it were HDFS. So you can spin up a cluster just when you need, point it at the S3 location for your table definition, and run your query right away. And finally, you can terminate that cluster when you're done. And you can use spot instances. So we'll talk about some of these other ones. But there are these higher level services you can use as well. Athena, Amazon Athena, for instance, where you can run a SQL query directly on top of your data in S3 without provisioning a cluster and pay just for the query. Allowing ad hoc analytics and BI use cases directly on top of your data lake. So there is a wealth of information here, but what I want you to take away is that, again, there's just a breadth of portfolio here that you can use the best tool for the job, right? There's not one perfect thing, and there are certain things that work better for the use case, right? So Redshift is awesome for your high throughput BI use cases where you need scheduled reports and you have lots of concurrent reporting queries. But your data lake is great to dive in on all of your data and run more ad hoc queries and data exploration, for instance. So S3, to recap, highly durable, right? Very cost effective, giving you around 2.3 cents per gig per month. And we announced things like intelligent tiering to move your data between our storage classes, which offer lower cost points for your data in S3. And it's very high performance. So when you look at, for instance, Presto, Spark, and you access your data over S3, because S3 is presented as a REST API, it can make multiple read and write requests over the data. So you still have very high performance for big data queries and analysis. It's, as I mentioned, very highly integrated, as you saw previously, with our ingestion, our security and monitoring, analytic services. And like you heard in the keynote, you have higher level services where you can train now recommendation, personalization services over the data in S3. So when I practiced this with some folks, they told me, Leif, can you find like a better picture for the security? Like that doesn't look secure. So my point is don't use your data lake, don't do your data lake like that. But the key thing is consider your security from the default. Encryption should be by default, right? We have the services and capabilities, virtually a checkbox to upload your objects using Amazon Key Management Service with encryption. So you should take advantage of that. Take advantage of the AAA features, authenticate, authorize, and audit. So IAM policies you can use to control access to your objects, down to the object level on the IAM users and roles, as well as the bucket policies themselves where you can control access. You can now also use the Glue data catalog resource-based policies, so you can control access at the metastore level of who can use those table definitions and databases to query the data in S3. So you have fine-grained control over that. You can use S3 VPC endpoints to keep the traffic within your virtual private cloud as well for additional layers of security. And audit and compliance is important for our most stringent customers, including FINRA, including Cisco, where they need the ability to see exactly what has occurred in the database in their data lake at any time. So CloudTrail now is enabled by default in AWS accounts, and you should check that regularly, audit that, make sure and we have things like guard duty that detect anomalies there. Take advantage of the lifecycle management policies. So you may decide, we want to keep the data for 7 years. But after that, we actually don't want to keep it because it's, we're not obliged to, and we don't want to be responsible for it. So you can even use lifecycle policies to expire the data, or move it to Glacier just to keep it long term, right? Glacier, our archive storage. And last but not least, of course, the compliance. We have the most security and compliance certifications, where you can inherit some of ours in that shared responsibility model, and you can build secure data lakes on top of AWS. Now, again, I hope you guys get it. See, now they have a data lake, and people are like rowing on the data lake, so they're using it now. The point is, you've built your data lake now, and you've collected your data, and you've identified some use cases, work backwards from that. The few things you want to keep in mind is you should, as much as possible, query that data in place. Use services like Hadoop on EMR and Spark and Flink that allow you to run PySpark jobs and Spark SQL and Hive directly on that data. That will reduce the amount of data moved from your S3 buckets and that sort of thing. That will help you achieve a higher scale. Use things like SageMaker or the deep learning AMI when you're running training jobs that can read and write the data from S3, store your model artifact in S3. That will also produce some additional efficiencies. Now, this is kind of on the flip side, right? When you have your data stored in S3, you may need to provide additional access mechanisms. Like at Cisco, they needed to provide API access to key value stores. They needed search APIs. And so from S3, you can easily load your data from S3 to a DynamoDB table using, say, for instance, Hive, which we have a DynamoDB connector for, or moving it to Elasticsearch for search APIs, full text search. So it's really good idea to get comfortable with the idea that it's like pickup trucks or cars, vehicles, right? You have pickup trucks, you have 18-wheelers, you have Corvettes, and sports supercars. Not all of them are going to be used to tow all the food that Cisco brings to reInvent or the restaurants near your area, right? So there are purpose-built engines and frameworks for the job, and it's really good to get comfortable with kind of manipulating your data and loading it into a purpose-built engine for your queries and your applications. Now, ML has been a big focus, and hopefully you guys enjoyed the keynote and some of the announcements we made there, but the ML is a key component, and I personally believe when we look at this in 50 years in the history books, this right now will be kind of a renaissance for machine learning, and I'll get off my soapbox here. But the data lake makes a great place to store and collect your training data, right? And we talk about supervised machine learning and unsupervised machine learning. You need high-quality data that's labeled, and you need to collect a lot of it to train an accurate model, right? So the data lake makes a great place to store that data so you can do more advanced analytics on top of it and progress to the right, like you saw with Cisco, progress to machine learning, predictive analytics, and statistics on your data lake. Now, I'll leave you with some best practices both on storage and compute for the data lake, and we'll talk about those separately. All right. So when you're talking about querying your data in S3, a key component of that is producing efficiency by reducing the amount of data that's read and written from S3. And so we can do that in 3 ways. The concept of a partition column is essentially that it adds a column from your data, and it projects that into the object name of your file. So S3 is a key value object store, right? And the key includes the column and its value. What that does is when you run a query and you produce you add a where clause or predicate to filter, that partition column will reduce the amount of data that's read from S3. So that'll reduce the amount of data scanned and make your queries faster And indirectly, it'll make it more cost-effective because you can run your clusters faster. The Athena queries, which are cost by per terabyte scanned, will become cheaper. So this is a key best practice that you should apply right away. Compression is another one where, again, the Presto frameworks and Spark support compressed data, gzip, snappy, bzip, LZO, that you can use to compress the data that's stored in S3 in that native format. So you can take advantage of that. That will, again, reduce the data scanned. And it will also reduce the storage consumption on S3, right? If you get a 5-to-1 compression ratio, you're using 5x less storage on S3, and you're saving money that way. So that's a shoo-in. And the last thing is using columnar file formats. So columnar file formats, essentially, what it is that when you have a data lake, typically you move to a more denormalized table structure, a physical data model that's more denormalized, meaning you're going to do more of your joins in advance before you store that in S3 to simplify your queries, right? And that eventually produces a very wide table with maybe hundreds of columns. You don't want to retrieve all 200 columns that you have in there when you're only querying just for 2 columns, right? So the columnar file format is stored in columns instead of rows. And when you, again, reduce the columns that you're querying in, say, a SQL query or a PySpark job, it reduces the data scanned, again, because it's just retrieving those columns, not every single column row by row. So again, another efficiency. So when you can combine all 3 of these, and this example here where we have some of our product reviews from Amazon.com, where we're storing it with a product category partition column. We're using Parquet, which is Apache Parquet, which is a columnar file format that you can store on S3. And we're using snappy compression for that optimization there. 2 other storage best practices. You can use the lifecycle rules to automatically tier the data, especially down to the infrequently accessed storage class of S3. In most cases, the data lake you're not going to be retrieving all of that data all the time, right? So the infrequently accessed storage class can present you some optimization in both your cost and S3. And you can use the S3 storage class analysis feature to recommend candidates of data that can be moved to infrequently accessed. And we now, of course, have the intelligent tiering in S3 as well that we announced. S3 Select and Glacier Select, I get this question a lot. Basically, what is it? They allow you to retrieve a subset of your data from an individual S3 or Glacier object using a SQL syntax. What that means in the context of a data lake, though, is that you actually want to push down S3 Select push down your predicates down to the S3 Select layer. And we recently added this feature into Spark and Hive and Presto on EMR that it will actually use S3 Select to push down some of your predicates down to S3 Select to improve the performance again and reduce the data scan. So take advantage of these, and you'll continue to see us expand the capabilities that we'll add for S3 Select and Glacier Select. Lastly, just want to recap on compute best practices. Because you've separated the storage from compute, you can use temporary compute resources. The data is persisted on S3, so you're not worried about that. So you can build up a cluster and tear it down when you're done if you're doing an ad hoc query, or if you're doing a PySpark job to produce some kind of output, or running ML training jobs, and you want to spin up a cluster, train the model, tear it down when you're done. So the ability to use temporary compute resources gives you that true elasticity of AWS that we provide. And it also presents the opportunity to use Amazon EC2 Spot, where you can use our unused capacity at up to 80 to 90% cost savings versus the on-demand EC2 rate. So you can use EC2 Spot with these ephemeral temporary clusters to save a lot of money, quite frankly. And we have a lot of EC2 Spot capacity. Let me just say that. So you can take advantage of that. You can mix and match EC2 instance types and EC2 families to get the best EC2 Spot rate possible. And with that, you orchestrate the compute, just like your job, right? You don't use, say, like a cron job. You actually want to use a scheduler, a workflow engine like data pipelines, step functions. Some folks use open source like Airflow, Apache Airflow from Airbnb or Azkaban to orchestrate the job, right, based on a schedule, based on some kind of threshold, or based on some kind of other predetermined requirements to trigger a job, right? You want that to be automated, and you orchestrate the cluster itself with the job, right? So you're going to use the AWS SDKs to provision an EMR customer or to run an Athena query or SageMaker training job, for example. So you orchestrate the compute with the job itself. And like I mentioned, when you use your data lake, think about how you can really provide access to the data for all your customers, right? Maybe Athena or EMR isn't the perfect fit for the type of queries they want to run, so you can load some of that data that they need into DynamoDB, Elasticsearch Service, Neptune for graphs, or even the time series database that we recently announced. So getting comfortable with that capability of using just the right engine. You have access to database engines that you probably wouldn't have had access to before, and so it opens up a lot of opportunities to really experiment, start small, and fail fast. This morning we announced the data lake formation in preview, and we've had the data lake on AWS solutions on our page for a while now, and we've added things like Active Directory features. So you could take a look at this. You can take a look at our new data lake formation as well. And this is one we'll continue to expand. So this is the same one that Sysco started with and extended, right? So you can start with this and expand it to your business needs. And this is by the way, this is one-click CloudFormation, deploy the whole architecture, the APIs, Lambda functions, S3 buckets, et cetera. So want to just recap and thank you all for your time. Think about, again, the decoupling of storage compute when you're building the data lake. If you're not doing that, you're really missing out on one of the key components. Think about how it can grow your analytics capabilities. Right? You can move away just from scheduled, formatted reports, allow people to run ad hoc queries to find exactly the data you need, and you can expand your analytics to more users than ever before. Right? Previously, you might have been constrained on your resources, who you allow to query your data, and now you can expand that virtually infinitely. Centralize and secure using the data lake, so you can use S3 as that main storage, and allows you to use consistent security bucket policies over your data. Use the cost optimization features like Spot and temporary clusters. Use the open data formats and the best practices that we talked about, like Parquet and partition columns and compression. And give yourself flexibility. That's really important, to give yourself that agility, that nimbleness, if that's a word, where you can use multiple tools and experiment very quickly, so you can try new things and find out what's going to work best for you. And so that, thank you very much. We really hope to get your feedback on the session, so please fill out the feedback in this mobile app, and we'll be able to take some questions. Thank you.
Now I have to create another zone in the data lake to represent the latest and greatest of the order item. What is the best practice for that?
So the question was, what is the best practice for collecting and presenting the latest and greatest data with the date as the partition column? Is that right?
Like suppose I have an order ID.
Yep.
It got updated, say, 3 times in a week.
Mm-hmm.
So day 1 I got just the data end of the day. It is a day 1 partition, day 3 partition, and day 5 partition. Now business wants to know for the order ID 100, I want to know what is the latest information. It is the order ID is got segregated across the partitions. So what we are doing is we are actually creating another zone called latest and greatest, and always consolidating it. So what is the practice you follow?
You want me to take it?
Yeah.
All right. So when you traditionally look at it, right, something like an order is just a transaction, right? So when we think about data lakes, we think about going at 2 speeds. So we have our data lake for more of a loosely coupled analysis. Transactions that you're talking about, we have a whole warehouse for it. So we put it in the staging area, ramp it up all the way to the warehouse, to the data mart area, and then use that to feed back into the lake. So we are always pulling the latest and greatest from a transaction perspective in this case. The value of the data lake for us is taking the transaction, combining with the observations and interactions which are not as structured and not part of our Redshift infrastructure to give us the value that we need. So we are not trying to solve all design patterns in the lake itself. It's the opportunity where we are trying to use the right tools for the right job.
But when you put the warehouse and building the dimensions and facts there,
Yes, we are.
with the complex data components, I want to use the lake to represent what is the latest information.
Yes, and that could be your design pattern. And offsite, we can discuss more in detail. We're talking about one implementation where transaction is one way and observation and interactions are other. All right.
So we have EMR as the self-managed ETL process on one hand, and also Glue was like AWS fully managed ETL too for you.
Yes.
We are playing with Glue a lot, but we're running into a lot of limitations here due to like the data size, that sort of thing. Do you have a guideline on when to take Glue?
Yeah. You want me to take?
Yeah, I'll take them.
All right.
Yeah.
So you want to take it?
Go for it.
No, I can talk about our implementation, and Laith can talk about the best practice. Which one would you like? You want to talk the best practice?
Yeah, I could mention best practices. So Glue, as you said, provides a managed ETL environment with Spark, with both PySpark and Scala now. And so the question for everyone was, when do you kind of decide between using EMR as a self-managed Spark environment versus Glue? And I would say it's really not kind of mutually exclusive. I think you may find that some jobs kind of lend themselves to Glue very easily, where you may have more complex jobs that are longer running, right? Things that take a lot longer and more complex, more data. They give you more control over Spark execution memory, et cetera, where you use it on EMR. It's not really, there's not a hard and fast rule, but I would say it doesn't have to be all or nothing either, right?
And just to build on that, right? So when we went live, we didn't have Glue. Glue was not GA at that time, right? So what we did was we did a classic 80-20 Pareto. We said 80% of our ETL loads are okay the way they are. 20% of them we are having issues meeting the SLAs. We are not able to load them on time. So we rewrote them on the EMR stack that makes it distributed and run faster. That's how we solve it. And right now we are actively looking at Glue. So we use Glue for cataloging a lot, but we don't necessarily use Glue for our ETL jobs.
Exactly.
Yeah, sure. So the question was, we had a custom integration tool called Gravity, and we wanted to give you more details on that, right? So when you really look at the data lake reference architecture, it does few things very well, right? It gives you an endpoint. It hooks up into AWS services where you can create packages and do a whole lot of other things. But from an ingestion perspective, ingestion is very specific to how you implement, right? Ingestion is very specific to how you partition the data, how you make it compressed. What are the denormalized tables you're going to build that will give you a perspective on your transactions? So all the best practices around compression, around making sure that the partition is selected the right way, the right join conditions are updated, is happening in that custom module. And we have a demo tomorrow where we'll be opening it up and then showing you how Gravity works in detail.
My question is more around like, especially if you're investing relational sources, you don't want to tax the relational operations system.
Correct.
Like a CDC tool for that, or you use tool for
Yeah. So the question is that if when we pull the data out of a relational tool, we don't want to tax the relation system. Did we use CDC? The answer is no. So we did not use a CDC tool. The input on our lake from a relational perspective is backfeed from our Redshift environment. And we load that in batch.
We have a lot of clients separated, we have to partition it out. Is it best to put the partition at the site level, or like you had that product level, some combination thereof?
Yep. So the question is what is the best practice or recommendation for partitioning your different customers' data? I think it will depend, based on your bucket policies, right, and what are the querying patterns. You may go as high as putting that data in different S3 buckets, or you may include it in the S3 partition column. The thing to remember, though, if you put it in a partition column, is the key value of an object is not encrypted, right? So if you're putting any sensitive information there, it should be some kind of hash or something like that, where you then query based on that. But if you want to do that, you can use the partition column in the S3 key, and you can control a bucket policy through the prefix, right, of the key. So you can say, this customer has access to S3 bucket / customer equals, et cetera, and they'll have access to that prefix through the bucket policy or IAM policy.
Would you still get it twice in some cases, or is that, like, if I need to partition it different ways?
Yes. Yep, so the question was, do you sometimes have to partition your data multiple times or keep some copies of the data? In some instances, yes, depending on how diverse those query requirements are.
And I'll add one thing to it, right? Space is cheap, confusion is not cheap. So that gives you the answer.
Yeah, especially when you have big different query patterns, right? That's the key thing. Before we even go into partition columns, you may use something like a date time or something to partition the data initially, but once you start to understand and look at the query history, what is everyone filtering on, and where are the joins, where are the where clauses on what column, then you'll start to get a better intuition. Okay, maybe we should partition the data on this other column, or do some nested. You can nest partition columns as well, so you may end up doing that as well. And I think we're out of time. I think we're going to have to come down stage. If you guys want to stick around, we'll come down here. Thank you very much.
Thank you. Thank you.